What if the next major cosmic catastrophe doesn't target Earth, but instead zeroes in on Mars? Astronomers from Harvard are sounding the alarm about this possibility. The interstellar comet known as 3I/Atlas, which was initially thought to make a safe flyby, is now projected to come perilously close, within the distance of Earth's moon from Mars. Fresh data from NASA confirms this, putting their leading experts on edge as they monitor for a potential collision that could reshape our understanding of threats in the solar system. If this unpredictable space object beats the odds and strikes, Mars could turn into the epicenter of an unprecedented event in our cosmic neighborhood. But how serious is this danger, really? And what factors are prompting the most pressing alerts from Harvard and NASA yet? At Harvard's Center for Astrophysics, the initial alert didn't originate from an observation through a telescope, but from a narrowing error range on a computer display. At 2:13 a.m., a standard orbital calculation for 3I/Atlas completed on the department's powerful computing cluster. This time, the results stood out. The comet's path was closer and more precise, with the nearest approach to Mars reduced by almost 400,000 kilometers from the prior week's estimate. It wasn't a bullseye, but it now fell well within the orbit of Phobos, Mars' closest moon. The uncertainty margin, previously spanning millions of kilometers, had shrunk to less than the span from New York to Los Angeles. Within hours, secure emails and urgent messages flooded collaboration channels. Graduate researchers launched Monte Carlo simulations, incorporating inputs from the James Webb Space Telescope, JWST, and the Very Large Telescope, VLT. Each additional data point from global telescope networks edged the trajectory slightly nearer to Mars. By midday, a preliminary press release was being reviewed internally titled Potential Mars Intersection Urgent Review. Professor Loeb's group wasn't isolated in their concern. Discussions spanned the campus, involving orbital experts from the Black Hole Initiative and the Minor Planet Center. One researcher, eyeing the updated covariance matrix, messaged succinctly, "This isn't a drill. The orbital uncertainty ellipse, a graphical tool astronomers use to depict possible positions, had sharpened dramatically." Just 2 days before the public announcement, Harvard's internal assessments indicated a 10-fold increase in the collision probability with Mars, though the overall chances remained slim. This shift was sufficient to activate a high-priority alert. The university's formal statement was restrained, but internally, the atmosphere was charged with urgency. Every incoming data was recorded, time-stamped, and verified multiple times. Harvard's simulations, updated hourly, revealed a consistent pattern. Without a significant gas release altering its course, the comet would skim dangerously near Mars, where one erratic burst could alter the outcome. The choice to inform the public was deliberate, given the dwindling safety buffer and NASA's involvement. Staying silent posed greater risks than raising awareness. Once the release went live, NASA's Jet Propulsion Laboratory, JPL, promptly sought Harvard's latest orbital data. The transition was seamless. For the first time, global focus moved from scholarly prudence to active planetary protection. Lingering in every Harvard lab was the question, what if the upcoming data point locks Mars directly in the path? At NASA's JPL in Pasadena, receiving Harvard's data sparked an immediate reevaluation. Trajectory specialists, experienced in modeling near-Earth asteroids, redirected their efforts to 3I/Atlas. New astrometric measurements from the Hubble Space Telescope and terrestrial observatories necessitated another adjustment to the close approach figures. The anticipated buffer, once equivalent to several planetary widths, had contracted to lunar mission scales. As of September 14th, the optimal projection placed 3I/Atlas at 1.95 million kilometers from Mars, under 6 times the Earth-Moon distance. This alone wasn't alarming, but the comet's retrograde, high-inclination trajectory, intersecting Mars' orbit at about 87 kilometers per second, raised red flags. At such velocity, even a minor contact would release energy unmatched in observed history. Each fresh data input refined the uncertainty ellipse, and JPL's Monte Carlo ensembles subtly shifted the probability toward the Planetary Defense Coordination Office's PDCO critical limit. In the operations room, lead analyst Dr. L.C. Jones discreetly elevated the monitoring status. The comet now qualified for intensified review, a designation for threats that might endanger operational assets or invoke global protocols. Agency-wide verifications ensued. The Mars Reconnaissance Orbiter was assigned frequent imaging of the approach vector. Goldstone's Deep Space Network antennas were booked for radar scans to detail the nucleus and velocity. PDCO liaisons attended daily updates, underscoring the shift from theory to practice. NASA's outward communication stayed balanced, but internal agreement was firm. The low probability risk now warranted full institutional focus. Both Harvard and NASA's analyses aligned on one key point. The error margin had narrowed to where defense measures were obligatory. The coming weeks would reveal if 3I/Atlas merely brushes past Mars, or if the red planet is now targeted by an interstellar intruder. Central to the 3I/Atlas enigma is a pattern that challenges comet norms, not erratic, but rhythmic. Every 17 minutes, precisely, the comet's tail releases a controlled gas burst. Data from Chile's Gemini South Telescope, corroborated by Hawaiian arrays and orbital instruments, verifies this cycle, accurate to seconds and persisting for days. It's evident in brightness fluctuations, a repeating sawtooth waveform. Spectral analysis detects spikes in cyanogen and carbon monoxide, classic signs of cometary venting. Yet, the precision is extraordinary. Typical comets expel gas messily from solar heating on irregular surfaces. In 3I/Atlas, the eruptions occur like timed mechanisms. VLT observers noted each plume's orientation subtly influencing the velocity. Overnight, these cumulative pushes alter the path noticeably. Harvard's light curve records show tiny accelerations syncing with the bursts, integrated into trajectory forecasts. The ramifications are concerning. If these act as thrusters, the comet isn't passively coasting, it's maneuvering. This 17-minute rhythm, confirmed worldwide, adds an unpredictable element to gravitational predictions. For defense experts, each burst could adjust the safety gap. Upcoming eruptions, scheduled for telescope observation, are monitored intently. Is this a natural phenomenon or anomalous? As the Mars rendezvous nears, this clockwork trait fuels debates from Cambridge to Pasadena. No solar system comet behaves thus. The inquiry shifts from destination to motive and method. Mars has sparked unprecedented speculation, not as a goal, but a barrier. Across podcasts, panels, and online discussions, the query surges, could Mars intercept a threat meant for Earth? A recent PopSky survey found 60% agreeing, dubbing Mars a celestial protector. The rationale: Mars blocks the path, with Earth safely distant. But data complicates this. At 3I/Atlas's mass, an impact equals 2 million megatons of TNT, sufficient to fracture crust, melt ice, and propel atmospheric shockwaves. Debris could scatter interplanetary, some reaching Earth velocities. Thus, Mars bears the impact, but repercussions might extend. Planetary expert Dr. Nia Tran, a streaming regular, analogizes Mars as a bumper. It absorbs the strike, but shards rebound unpredictably. Simulations confirm a halo effect, with dust and rocks potentially intersecting Earth's orbit, though minimally risky. Social platforms buzz with hypotheticals. Some hail Mars as a martyr, others fear cascades. Could it alter orbits or destabilize the system? Dynamitists unanimously say no. Mars' mass dwarfs the energy. Yet the mental impact is profound. Humanity witnesses a defense saga unfold live, with another world at stake. What do you think? Might Mars truly safeguard us, or could fallout exceed expectations? Share below and subscribe for ongoing cosmic insights as the 3I/Atlas narrative evolves. A lone diagram conveys what endless figures cannot. In NASA and Harvard control centers, Monte Carlo outputs dominate displays, a diverging array of potential outcomes. Each path simulates 3I/Atlas's route to Mars. The central best fit line sails through at 1.95 million kilometers, but the fringes, fading outward, embody the slim hazard keeping teams vigilant. These lines stem from exhaustive calculations. Each Hubble precision or JWST clarity refines the vector, tightening the spread. The primary cluster, 1 sigma, rules out collision. Yet 3 sigma outliers graze Mars' gravity. The extremist dips to 50,000 kilometers, nearer than Deimos. To novices, the gap seems trivial, but in mechanics, it's vast yet cautionary. Most futures are benign, but the faint peril tale mandates protocols. Analysts use density and sigmas. Even minuscule odds, scaled by stakes, demand heed. This diagram, evolving with data, shrinks uncertainty but leaves room for surprise. Bands denote confidence, deep blue for assurance, yellow for anomalies. The September 16th ensemble shows edges contracting, outliers mostly clear of Mars. But not entirely. Hourly inputs erode the risk tail, the core path stays safe. Cautious experts persist until all threats vanish. The once solar system-wide margin now pixels thin, yet enough to rivet focus on this icy interloper. For policymakers, the diagram's form dictates if Mars logs a miss or hit. Until final data, possibilities linger, a timer to resolution or calamity. NASA's PDCO follows escalation protocols, typically quiet for non-Earth threats. But 3I/Atlas's Mars proximity prompted an anomaly. JPL's trajectories met criteria: narrowing ellipse, risk within gravity, impact scenarios visible. Adapted from Palermo scales, thresholds trigger when consequences loom, even remotely. This hit when September 16th runs showed orbits at 50,000 kilometers, nearer Deimos. Not probability, but implications. Mars hosts multinational assets worth billions. Hours later, a secure briefing convened ESA, Roscosmos, CNSA, ISRO. Agenda: data review, mission risks, contingencies. No public word. Classified directives urged heightened telemetry, repositioning prep. The escalation spread. MRO imaged paths, DSN radar maximized. ESA reviewed orbiter backups. Privates like SpaceX assessed launches. Thresholds weigh outcomes, acting pre-closure. Alerting for 3I/Atlas, acknowledged shrinking margins necessitating decisions. Planetary defense pivoted beyond Earth. Next bursts could tip from miss to event. With 10 billion tons and a 400-meter metallic core, a 3I/Atlas strike equals 2 million megatons, thousands-fold Earth's nukes. It'd carve a 60-kilometer-wide, 5-kilometer-deep crater, eclipsing Arizona's Barringer. Shockwaves would hurl dust supersonically. Nearby craft, MRO, Trace Gas Orbiter, Tianwen-1, Perseverance, faced debris storms, severing comms, erasing data. Simulations concur, nothing survives blast zones. Perseverance, 3,000 kilometers distant, might endure. Orbiters risk ejecta. Seismic waves could unsettle landers globally. Orbital debris clouds threaten SATs long-term, disrupting monitoring, mapping, relays. For builders, it's heartbreaking, a wipe of generational work. Stark stats, immense energy, vast crater, billions at stake from one projectile. Eyes glue to updates. One pulse could mean loss of Mars' human legacy. Beyond local, geologists model aftermath. Vaporized tons form escaping clouds, birthing enduring debris rings shadowing surfaces, endangering craft. Thin air allows global storms, inducing winters, temperatures plummeting, stalling missions decades. Dust clogs panels, obscures views. Impacts accelerate atmospheric bleed, thinning further, dimming habitability. Ice sublimates briefly before void loss. Fragments escape to space, potentially earthbound, warranting tracks. Recovery? Mars bears ancient scars, but this observed wound redefines models for climate, geology, life hunts. Ripples echo in Mars as home talks. Shoemaker-Levy 9's 1994 Jupiter strikes, Earth-sized scars, spurred defense shifts. Tools emerged for Earth threats, but Mars lacks. 3I/Atlas exposes gaps. No deflection for interstellar speedsters. No Mars alerts. No treaties. Policy drafts circulate for data sharing, coordination, voluntary. Privates push protections for futures, but tech lags, can't divert 10 billion ton, 90 kilometers per second objects. Shoemaker-Levy warned, 3I/Atlas limits, next could hit populated worlds. Discoveries test readiness for survival. Subscribe for cosmic challenges, safer star futures. In July 2025, NASA Harvard confirmed 3I/Atlas at 87 kilometers per second, nearing 50,000 kilometers in simulations. 20,000 plus pages detail alert rises on non-zero odds. Pulses, signatures unresolved despite simulations. Mars fate, missions hinge on tracking, defense leaps, no deflection tech exists. 3I/Atlas reminds, observatories, research insufficient, protection incomplete. Next, by astronomers, all for defense.